Okay, welcome everybody. This is section 3.1. We're going to start using equations and corresponding graphs for quadratic equations. So we're going to look at different quadratic equations and different parts of it and label them and find answers that they ask for. So we haven't done really a lot with quadratic equations, so we're doing it now. So let's see. It's hard for me to set this up just exactly right so I can see it correctly. Give me a second. Okay. There we go. That's better. Okay, so first, let's do part A, find the domain and range. By the way, this is the function we're dealing with here. This is what, if I put it in the calculator to graph it, that's what the graph looks like. That's what the graph of this function looks like. So find the domain and range. Don't forget, when we're dealing with this, these endpoints are arrows that go down, and the far left one goes down and to the left. The far right one goes down and to the right. So the domain for this function, if you look, it's hard to show, but I'm going to show it up here. The bottom is going down and to the left side. And so it's going over here to -20. If I go down any more, it goes to -30. If I go down into the left more, goes all the way to -infinity, especially this other one here. It's going down and to the right. So it's going over here to 10, and then on the x-axis, and then it's going to 20. And eventually, if you go down far enough, it's going to infinity. So the domain for this function, it's like I said, it's hard to see because it doesn't show the arrows, but there are arrows here. They're not just going down, they're going down and then to the sides. The farther down you go, the farther to the sides they go. So the domain for this function is it goes from -infinity to +infinity. Because the domain is what the x-axis, this graph goes all the way down and to the left. You see it's going all the way to infinity. If the graph was up here, is better. I mean, it's exaggerated, but it's going down and to the left. The farther down you go, the more the left you go. It is moving to the left and it is moving down. Now the range is different. The range, don't forget, range is the y values. This is the highest, if I could draw it, this is the highest y value, and the lowest y value goes down way down here, -10. It goes all the way down to -infinity. So the range, the lowest value is -infinity, the bottom part, right? And the highest value, it looks like it's going right here to 3. And it is touching 3. The vertex, or the top of the parabola, is always touching the point that it's at there. So it is touching this point here, 3. So this is the domain and range. Now the vertex is the point of the top or the bottom, the highest point or the lowest point. If the parabola looked like this, the vertex is the lowest point. If the parabola looks like this, the vertex is the highest point. So this vertex, can somebody tell me the coordinate of the vertex? Anybody know the coordinate of that vertex?
Is it 2, 3?
Yes, X value is 2, the Y value is 3. So the vertex is, we always label it as a point, as a coordinate, and it's the X and the Y. That point labeled, if you just look at that dot right there, that coordinate, that is labeled 2, 3. Thank you. So next we're going to do, where is the graph increasing? And when we deal with increasing or decreasing functions, you know, here it says increasing then decreasing. When you deal with increasing or decreasing functions, or it's asking find the intervals for increasing and decreasing function, they're only talking about the X values. So we only want to look, when we talk about increasing and decreasing function, we're talking about the X values in interval notation, not a coordinate. So even though it looks like a coordinate, we're talking about it in interval notation. So if you look here, the left side of this graph, if you move from left to right, the left side of this graph goes up. This graph goes up until this point right here. Then it starts going down. So it's going up on this side from left to right. It's going up, it's increasing. Going up is increasing from negative infinity to what X value? The X value is going up until X value 2. At the vertex, it stops going up. That the vertex is the highest point in this case. Then it starts going back down. So it starts decreasing at 2 on the X value, and it's decreasing all the way over here because it's going down and to the left all the way to infinity. So domain, range, vertex, increasing. Where is the graph increasing? What X values are they increasing from negative infinity to 2? It's increasing all the way from here to here. This graph is going up. And then where is it decreasing? It's decreasing from 2 all the way, because this graph is going down and to the left from 2 to infinity.
Would it be, is it increasing to 2 or to 3?
No, it's increasing. We're only looking at the X values. Do you see it stops increasing at X value 2? Do you see right here is the X value? Even though it goes up to 3, but when we say an interval for increasing or decreasing, they want to know the X values that it's increasing. That's why I have the X values for increasing or decreasing. It's increasing from negative infinity all the way up to 2, the X value of 2. And then it's decreasing from the X value of 2 all the way to positive infinity. Does that make sense? Do you see how I'm only talking about, I don't want to know how high it goes. I just want to know where it's increasing or decreasing.
Are we going to do C, the axis of symmetry?
Oh, yes. I forgot all about that. Thanks. Does that make sense? Is anybody still confused? I see there's a couple of, when we say increasing or decreasing function, we don't care what value it is. Yes, that point is 3 on the y-axis, but it stops increasing at x equals 2. Do you see? This graph increases, but it stops increasing at x equals 2. Do you see it starts at negative infinity and it stops at x equals 2. Then it starts decreasing at 2, and it decreases all the way to infinity. And I'm talking infinities over here. Down there is negative infinity, but that's the y values. We're talking about the x values. This graph moves down and to the left, and it goes all the way to infinity, and it's decreasing. Does that make sense, Matilda? I know you typed something in the chat box too. You said the y values, but that's why I wrote increasing or decreasing. Only we want to look at the x values on where it's increasing or decreasing.
Can you hear me?
Yes.
Meaning we don't have to solve anything, just figure out where it's decreasing at?
That's it. What x values is it decreasing at? And it's decreasing, you know, it right here is the line. It's decreasing here from 2. So you see all this, the x value of 2, and it's decreasing all the way to infinity. Here it's increasing and stops at 2, but it started increasing at negative infinity. Do you see? If I go down far enough, this graph is going to be way over to the left to negative infinity. Visually, it's hard to see that because it's not even at negative 10 right here. It's only at negative 4. But if I go down further, if I keep on going down further, it keeps on going closer and closer to negative infinity. And we'll try another one. Oh, I still have to do the axis of symmetry. Axis of symmetry is really easy once you have the vertex. So we have the vertex. The axis of symmetry, part C, and it has to do with the same thing. It has to do with the same thing as we've talked to. If it's symmetrical, this is the axis of symmetry. I put a line right down the middle if it folds over. Axis of symmetry is always a line down the middle. Axis of symmetry, vertical lines always start with x equals. So the axis of symmetry is x equals, and then whatever the vertex x is, 2. You see it goes right down 2. Axis of symmetry is always labeled x equals, and wherever the vertex is at, this time the vertex is at 2, it's x equals 2. That's the axis of symmetry. So once you have the vertex, the axis of symmetry is just going to be that. But you have to label it x equals 2. Okay? And we'll do another one of these. I know it's a little confusing. I want you to notice also in this equation, before we continue on, here there's a 2, even though it's a negative 2, that's the x part of the vertex, and this is the y, that's the y part of the vertex. So when this is called a function in vertex form, this will always be the x part of the vertex. This will always be the y part of the vertex. And the sign will always be the opposite for the x part. For the y part, it'll always be the same. I think we're going to cover that later on. All right, let's try another one. So let me just, here's the equation, and I want to do the vertex first. Do you see? I can look at the graph, but I can go to here. The vertex has an x part and a y part. The vertex is always going to be whatever's inside next to the x. It's always going to be that number, but it's going to be the opposite sign. If it's a -5 in here, then we're going to put a +5 here in the vertex. And for this is the y value of the vertex, but it's the same sign. A -4 here, so we have a -4 here. The x part is always the opposite sign that's in there. The y part is always the same sign. Look at the vertex now when we're down here. Look at this coordinate. The x is 5. The y is -4. So that's the vertex. You see, you can look at it here, or you can get it off the equation. Either one is fine. Off the graph, there's a vertex, the coordinate, or you can get it from the equation. The opposite sign of the x here, and then the correct sign here. Perfect, Matilda. Oh, wait, you're not perfect. Sorry. You have to put the parentheses around it. All coordinates have to have a parentheses around them. Oh. So you have to make sure you have those parentheses around it. Okay, so we're going to keep on going. Let me erase this mess. So that's the vertex. Let's do the x-intercepts. Part A, x-intercept, is where the graph crosses the x-axis. And the x-intercepts, we have two of them. Look, the graph, here's the x-axis. We have two places the graph crosses the x-axis. At 3 and 7. Now, I think they might want you to write it in coordinate form. So don't forget, x-intercept is 3, 0. The y values are always 0, and 7, 0. X-intercepts. The coordinate form for those x-intercepts is 3, 0, and 7, 0. Remember, x-intercepts, the y is always 0. Okay. Now we have to find the x-intercepts. We did that. Oh, they said find the y-intercepts. Let's do that. Y-intercept is where the graph, y-intercept is where graph crosses the y-axis. But I can't, this graph keeps on going up and to the left. I'm not sure where it crosses. It crosses somewhere, but I'm not sure. Don't forget, y-intercept, x is always 0. X, maybe I should have written, instead of saying x is 0, x is always 0. Y, up here, the y is always 0 for the x-intercept. For the y-intercept, x is always 0. Here's my equation. X minus 5 squared minus 4. If x is always 0, I put a 0 in here and do the math on my calculator. 0 minus 5 squared is 25. 25 minus 4 is 21. So the y-intercept is x is 0. Y is 21. Do you see? We just put the 0 in here, and it tells you y equals 21 when you do the math. Don't forget, we got to learn we got to remember everything we used already. So if I drew this correctly, this would go up and up and up and up and up, and it would finally cross here somewhere at y21, because we put 0 into the equation. 0 minus 5 is -5. -5 squared, -5 times -5 is 25. 25 minus 4 is 21. So this right here is the y-intercept. So we've done that already. We've done that before. We haven't done it for a parabola, but it's the same process. Okay. So we did that, we did this, we found the vertex, the domain. Domain for parabolas always is -infinity to +infinity. Do you see this graph goes up and over? Domain is what the x values can be. Do you see it's going to the left? So it goes all the way up and to the left to negative infinity. And here it's going up and to the right to positive infinity. That's the domain. Now the range is the lowest y value, which is -4, and remember it's touching -4. The vertex is always touching. From -4 is the lowest. The highest y value goes up to infinity. And finally, the axis of symmetry. Can somebody tell me the answer to the axis of symmetry?
5?
Is it
Yes.
-4?
No, it's always the x.
No, I'm sorry,
value.
5.
X equals 5. You have to say x equals. In the homework, they'll have the x equals already typed out, and you just have to type the 5 in there. But the axis of symmetry is a vertical line. All vertical lines start with x equals. So the answer for vertex is x equals 5. You see it's going right through 5. The center of this parabola goes right through 5. X equals 5. And that's number 2, problem 2. Everybody okay? Does that make it a little bit clearer so far? I'm sure we have another one. Yes, we do. Good. Oh, see, they don't even ask. Number 3, they're not asking everything. I'm going to try to ask everything. Let's see. So somebody tell me what the vertex is. Type it in. So first, we're going to find out what the vertex is. It's always going to be a coordinate. The vertex is not 5. It's always going to be a coordinate. So you're thinking the axis is symmetry. Yes, but you didn't put the parentheses. Oh, and it's not a 3. Remember, the vertex, this is the x value, but different sign. A -5 changes to a +5. And the y value is the same number, 4. So the vertex is 5, 4. Look at the vertex is the highest or lowest point. Right there's the vertex. The coordinate here is 5, 4. You can get it off of the graph, or you can get it from the equation when it's in vertex form like this. Only when there's a parenthesis square plus another number outside of it. So this is called vertex form. So type in the axis of symmetry. What's the axis of symmetry? X, yes, axis of symmetry always starts with x equals, and it's always the x coordinate of the vertex. X equals 5. Domain, I'm just going to go over the domain again. Domain for parabolas is always negative infinity to positive infinity. You see this graph goes off and to the left. It's hard to see that, but this graph goes, I mean, way over here at negative infinity. You just have, do you see it's going down and to the left? You just have to go down far enough for it to go to negative infinity that way. And you have to go down far enough on the right side for it to go over here to positive infinity. The range, the lowest point is negative infinity on the y-axis. The highest point on the y-axis is 4, and range you're always touching at the vertex, so you have to put the bracket there. Vertex, axis of symmetry. Now the I'm not going to do the X-intercepts because it's really hard to see. It'd be like, it's something like 3.5. It's really hard to tell. and 6.5, right? Those are the intercepts where the graph crosses the x-axis. So I'm not too worried about that. If you can't see it there, they're not going to show it. All right. But, I mean, this is a typical test question. What is the vertex? The vertex is 5, 4. Opposite sign of this and the same sign of this. This is the x part and this is the y part. Or you can get it right off of here. The coordinate is x5, y4.
So they didn't want, for this question, they don't want the axis of symmetry, domain, and range. They just wanted the vertex, right?
Right, right.
Okay.
I just added all that in there just
Okay.
to give us a little bit more practice. Same way with the next question. They're asking for the axis of symmetry, but first I want the vertex. So type in the vertex. The vertex. Type in the vertex. They don't give us a picture on a graph, so we have to use the function to get the vertex. Nobody wants to be the first to type it in? Okay, there we go. Yes, it's always the opposite sign in here for the x. It's a positive 5, so we put the opposite sign, -5, and it's always the same sign here. This is the vertex. If you have the vertex, then the axis of symmetry, x equals whatever the x value is, -5. So the answer to number 4 is x equals -5. Okay, everybody okay with this? I mean, that once again, that's a typical test question. What is the vertex or what is the axis of symmetry? And they just give you an equation like that. Okay. Number 5. Identify the vertex of the parabola and then write the equation in this form. Okay. Yes. Trying to figure out how I want to approach this. There's a couple of ways of doing this particular problem. This is how I want to approach it. For vertex, I'm going to put the little notes over here. Vertex. Vertex always has the x value and the y value. Step 1. Do you see, it's not in vertex form. There's no square and then the number. There, it's not in vertex form. This is not in vertex form. We're going to change it to vertex form here in a little bit. We're going to actually change it to vertex form. But it's not in vertex form right now. I'm hoping this works so I don't have to show you the long, hard way of doing this. Actually, it's really not too long and too... Yeah, let's do it this way. Steps. Step 1, -b divided by 2a equals the x value. -b divided by 2a is the x value. So can somebody tell me what b and a equals? What does a and b equal? The formula x equals -b divided by 2 times a. What does a and b equal? Anybody remember how to find a and b?
B is -20 and
Yes.
A is 1.
Remember, A is always the number in front of the square, the invisible 1. A equals 1, B equals -20, and C equals 105. When we're doing it in the quadratic formula, A is the number in front of x squared, B is the number in front of x, and C is the number without the x. We only need A and B. B is -20. So I'm putting a -20 in the B spot, and A is 1. I'm putting a 1 here. So I'm going to put this in my calculator. Negative changes to a +20 divided by 2 times 1 is 2. So x, the x value of the vertex is 10. Be a little bit neater. The x value of the vertex is 10. All right, now we have to find the y values. That's step 1. Step 2, plug x equals 10, in this case, x equals 10 into original equation to find y. Here's the original equation. Do you see it says y equals x squared minus 20x plus 105. And I'm going to plug the x value in there, 10. And put this in my calculator. 100 minus 200 is 100. I think I get 205. Wait, that's not right. I get 5. 100 minus 200 plus 105. Can anybody verify? Put that in your calculator. You should get 5.
Yes, got 5.
So my vertex for this problem is 10, 5. Okay. All right. My vertex is 10, 5. Now I have to put it in this form. I have to put it in this form. I'm going to erase this top part here. The form is ax minus h squared plus k. So I'm going to erase the minus h and I'm going to erase the k. Can somebody tell me what goes here? What number goes here?
5. No?
Not 5, but you're kind of on the right track. Remember, what's inside here is the x part of this is the vertex we just found.
Oh, okay, so it'll have to be 10 then.
It's close to 10, not 10.
What?
You're closer.
-10?
-10. Remember, it's always the opposite sign of what's the vertex is always the opposite sign inside here. Remember we said if the vertex is actually 10, then inside here it's -10. Now the y part is going to be the same sign, 5. And what does a equal in our equation when we did it down here? 1. So I'm changing that just to 1. And in reality, when you have a 1 there, you don't need to have anything there. So you can erase the 1. 1 times that is the same. So this is the vertex form. Changing it to this form, do you see how it looks like that now? The A, there's just an invisible 1 right here. That's an invisible 1. Everybody okay with that? If we use this negative b2a and then we plug the answer back into the original equation to find y, we have the vertex, and then we can plug it straight into this equation. All right, we're going to do the same thing for number 6. So we'll do the same thing. We'll do this again for number 6. Let me erase all this except my steps. And I'm going to get rid of this and this. Okay, so let's do number 6. So A, B, and C. A is the number in front of x squared, B is the number in front of x, and C is the number without the x. There's A, B, and C. So to find my vertex, step 1, negative b divided by 2 times a. Negative b divided by 2 times a. B is negative 4. I have to put the negative 4 in that spot. There's a negative in front of it, but I have to put the negative 4 in there. And a is 2. When I put that in my calculator, negative times a negative is a positive, so it's 4 divided by 4. I get 1. And I'm going to put over here, I always put a v in front of the coordinate when it's a vertex. The x part of the vertex is 1. The x part of the vertex is 1. The y part, y equals 2 times x squared minus 4 times x plus 12. Do you see? Plug the answer. We got 1 for our answer up above. Negative b over 2a equaled 1. We got it right here. And when I plug 1 back into the original equation, x's, that's supposed to be a plus 12. I get 2 minus 4 is negative 2 plus 12. I think I get 10. 14. Yes, I get 10.
Yes, it's 10.
So I get a y value of 10 for my vertex. That's my vertex. Find the vertex. That is the vertex. 110. But now I need to put it in vertex form. Now the answer has to be y equals a times x minus h squared plus k. They use h and k. For vertex, they just use h and k. So what do I put? What number do I put? Give me a second. I'm trying to get the color there. What number do I put in here?
-1.
Yes, the opposite sign that's on the vertex, -1. What number do I put right here?
10.
Positive 10. A plus 10. And that's my vertex form. So when you put it in vertex form, it's always going to be the opposite sign for the x and then the same sign for the y. That's it. There's another method of doing it. It's so much more confusing. I know this has only 2 steps here. It's still probably a little confusing till you practice it. But there was another steps that we had to do that was 10 times harder. But this seems okay. Any questions on this so far? Okay. Seven, 8, and 9. Word problem alert. Word problem alert. Okay. So on these word problems, it's the same thing we've been doing finding the vertex. I'm going to tell you right now, it's the same thing we've been doing. In fact, I say let's just find the vertex on these right now. It might be easier to find the vertex on these right now. So if it says what rainfall produces the maximum number of mosquitoes. So let's read the question. The number of mosquitoes, MX. This stands for the number of mosquitoes. In the equation, what does MX represent? Can somebody tell me, other than mosquitoes, is there another letter that it represents? It's
Y.
yes. I just, you know, it's a function, and this represents the Y value. I want to make sure everybody understands the number of mosquitoes represents the Y value. Y equals this. And I'm going to put this in order of, from the way we're supposed to have it in the quadratic formula. The x squares come first, negative x squared plus 16x. Do you see? I'm just putting this first because the x squared always goes first, and then the x, and then there's no number after it. So I'm just putting a 0 just to show you. This is how we write a quadratic formula. So A equals, what does A equal?
-1.
-1. So there's a negative in front of the x squared. So A equals -1, B equals 16, and C equals 0. Even though we're not using C for the vertex, I just want you to, quadratic formula, if we were going to use a quadratic formula, C would equal 0. There's nothing there. So to find the we got to find the vertex. Don't forget, we're going to find the x value and the y value. First thing I'm going to do is find the x value. Negative b divided by 2 times a. Negative b divided by 2 times a. And the b part is 16. The a part is -1. When I put that in my calculator, I get 8. Okay? So now I want to find the y part. And the y part, we just plug it into the equation. Same like we did above. The y part, we plug it into the equation, the x value. The x value is 8, so I'm plugging 8 into the equation. And I'm going to put that in my calculator. 16 times 8. And I get 64. I hope that's right. Somebody better be checking my work. Everybody okay with that?
Yeah, that's what I got too.
Good, good. Just want to make sure. Oh, well, at least one person is helping me out. Okay, so we're not done. Let's read this again. So we know MX is that Y part is the number of mosquitoes in million. In a certain area, depends on the June rainfall in inches. So if you look, the June rainfall, even though it doesn't tell you, X is the rainfall. Because there's only an X and a Y. X is the rainfall. So what rainfall produces the maximum? By the way, this is a parabola. And since there's a negative in front, remember, we already talked about a parabola like this is an x squared, y equals x squared. That's a parabola. If I put a negative in front of the x squared, we talked about this last time, I think, it's now a parabola that looks like this. And the vertex is a maximum. Do you see? Down, if it's just like this, the vertex is the smallest part, the minimum. So since it's the negative in front of the x squared, the vertex is a maximum. What rainfall produces the max number of mosquitoes? Well, we already said Y is the number of mosquitoes in millions. And then, so that means X is the rainfall in inches. It says somewhere rainfall in inches. So the answer to this question is 8 inches. The answer is 8 inches. And I mean, if they said what was the maximum number of, because this is the vertex, what was the maximum number of mosquitoes? The answer is 64 million, because they said the answer was in millions. So we got 64, but it's 64 million. If this place has 8 inches of rainfall in June, there will be 64 million mosquitoes running around. That's what it's saying. Okay, everybody okay with that? So in each of these word problems, we're going to find the vertex, and the vertex is going to give us the answer. I think I forgot to do part of the question up here. I want to go back to 6 just for a second. Can somebody tell me what I got for the vertex? Oh, I think I did it. What did I get for the vertex for number 6? Did anybody write it
1
down?
and 110.
110. And we had to put it, remember we had to put it in vertex form, y equals a times x square plus y, and we put a 10 here, and we put a -1 here, right? I forgot to mention, I don't think I mentioned it, but I forgot to mention, don't forget, a equals 2. So we have to put a 2 there. So go back to number 6 and make sure you put a 2 there. Don't forget a equal 2. So whatever a is, you have to put it in that vertex form.
Yeah, you wrote it and left it as an A and not the 2.
Okay, that's why I kind of remember in the back of my head, I forgot to write that 2 down there. But you have to put a 2 there. Do you see the vertex form up here? The vertex form up here has the A. You have to put the A in there. Up here, the A was 1. That's why I wrote it as an invisible 1. But down for the other one, we had to add that in, the 2. Thanks. All right, number 8. So once again, by reading this, it says where C is the cost, X is the number of watches, how many watches, the lowest. Do you see they're asking for the, instead of a maximum, they're asking for the lowest. Because this is a positive X square, the parabola looks like this. And the vertex is the lowest form, the smallest, the minimum. So they can call that the lowest or the minimum. So the vertex is the lowest point because there's no negative in front of the X square. So I'm just going to find the vertex, just like as soon as I see this, it's once again, it says C is the cost. So Y is the cost. And then the X is the number of watches. The X is the number of watches. It's good to know this because once again, X and Y, the X is the number of watches. This is the cost. This is the number of watches. So to find the vertex, A equals 2, B equals -184, and C equals 4532. To find the X part of the vertex, -B divided by 2 times A, -B divided by 2 times A. B is -184 and A is 2.
I got -46.
Thank you. Oh, wait. It's a negative and a negative. So when you put that, it's a +46. So Make sure there's a negative in the formula, but B is a negative 184. So if you have a negative outside the parentheses and a negative inside the parentheses, it changes to a positive. So you should get a positive of 46. So the number of watches that produces the lowest cost is 46. So you have to make or operate or whatever they're doing. He's repairing 46 watches. How many watches must he repair to the lowest cost? The answer is 46 watches. That's the lowest cost. But now he says, what is the lowest cost? He wants the Y value. So the Y value is the equation Y equals 2 times X squared minus 184 X plus 4532. And I'm going to put 46 into it. The 46 watches makes the lowest cost. So I'm going to put that in my calculator. 2 parentheses 46. And then I'm going to square that. Minus 184 parentheses 46. Close parentheses plus 4532. And I get 300. I think that we're talking about dollars here. If we're talking about cost, it doesn't say anything else. What is the lowest cost? The lowest cost is 300. Did anybody else get 300?
I did.
Okay, good. Thanks. So everybody okay with that? All we have to do is find the vertex using what we've already learned. And each of these word problems, we have one more word problem. As long as it says minimum, maximum, lowest, or highest, you're going to find the vertex. Number 9, find the maximum height. In other words, do you see there's a negative in front of this parabola? Here's a parabola where it's y equals x squared. When you put once again, when you put a negative in front of that x squared, the parabola turns upside down. It flips. We talked about the negative in front. And here, for a positive in front of the x squared, you have a minimum. For a negative in front of the x squared, you have a maximum. There's a negative in front of this. They say, what is the maximum height of the object? Height is the y value. T is the number of seconds, or the x value is t. The x value is time. The y value is the height. So it's always good to understand what you're looking at in a vertex. Once again, if you have a vertex, my pen's not righty. If you have a vertex, the x value is the height. The y value is the time and height. So to find the x value, it's negative b divided by 2 times a. Negative b divided by 2 times a. And a is negative 16. And b is 80. B is 80. And a is negative 16. So I put this in my calculator. And I get 2.5. In other words, 2.5 seconds. So if an object is, I didn't even read the question. I already know. I saw maximum. I'm going to find the vertex. An object is propelled upward at a height of 96 with an initial velocity of 80 feet per second. And then the height is per second, every second. We want to know the height at 2.5 seconds. That's the highest part. At this value right here, the x value is 2.5. You see, that's the x value of the vertex. Now we want to find the y value, how high it goes. What is the max height? Well, the y value is the height it's negative 16 times x squared or t squared plus 80t plus 96, and we're going to plug 2.5 into it and put this in our calculator. Exactly as you see it with parentheses and all. And I get 196 feet.
196 too.
Okay, so you're throwing this object from a certain height. 2.5 seconds later, you know, it starts off at 96 feet above the ground or whatever, wherever they're at, and you throw it up. 2.5 seconds later, it's at its highest point, 196 feet up, and then it starts coming down. You know, we started here at 190 or at 96 feet. We throw it up there, and it stopped at 196, and then it started coming back down. And that's the answer. What is the maximum height? 196 feet. How long did it take to get to the maximum height? 2.5 seconds.
I have a question.
Yes.
How do you, if you can go over again, how did you determine which one was, like by reading the word problem, how you determine what was X and what was Y by reading the
Exactly.
word problem?
Okay. Let's take a look at that. A lot of times they let you know with the letters in front. Look at this. That's the Y. Would you agree that's the Y?
Yes.
The Y is Y equals, right? The function equals. So that's an H, and so that's the Y value. Then it says T seconds. So these are the X values. You always have the X values in the equation. These are the X values. X values are time, and the Y value is height. Okay, so let's go back to number 8 and look at that really quick. Because yeah, that brings up a good point. I actually get that question quite a bit. If we look here, the cost of operating a shop is given by this. Do you see the Y value is the cost? It actually starts with a C. And then it says here, X is the number of watches repaired. So the X value is the number of watches repaired. The X. Y is the cost, and the X's are the watches repaired. What is the lowest cost? Do you see when they say the cost, then you're trying to find the Y value. What is the lowest cost? We're trying to find the Y value of the vertex.
Okay.
If they say, how many watches must be repaired for the lowest cost, remember the X is the number of watches repaired. The number of watches. Okay, let's look at the number 7. This function starts with an M. Mosquitoes is the M. The number of mosquitoes is the Y value. The X value, it says in the rainfall in June, rainfall is in inches. So even though if Y is the mosquitoes, then X has to be the rainfall, the inches of rain. Sorry, it's really hard to write with this pen. So the X has to, I mean, this number 7 is the hardest one, but if Y is the mosquitoes, then X has to be the number of rain. Because if you only have 0 inches of rain, you're probably going to have no mosquitoes because mosquitoes need rain, right? If you have 0 rain, 0 times, when you do all this math, you get 0 mosquitoes. 5 inches, you get more mosquitoes. If you had 10 inches of rain, you're going to get a lot more mosquitoes. That's why they always say in this, you know, whenever we have mosquitoes, oh, when we get a ton of rain, they say, well, get ready. In 2 weeks, we're going to have a ton of mosquitoes. Did that help?
Yes, that did help.
Good, good.
Thank you.
All right. Let me hit stop recording.